Hello everyone, this video will be about the application of 5G in smart cities. Before we begin, I'm sure you guys have already heard of 3G and 4G. In fact, it is most likely that you guys are already using this on your smartphones. Well, 5G is the next big step or generation, as the G in 5G stands for generation, making 5G the fifth generation of wireless technology just after the current 4G LTE. 5G uses similar encoding to the LTE, which is OFDM, that stands for Orthogonal Frequency Division Multiplexing. However, the characteristics of 5G are said to differ from the current existing 4G network. So let's take a look at some of the characteristics of 5G network. First off, 5G network have data rates that can theoretically go up to 20 gigabytes per second, making it a huge improvement as it can be 10 to 100 times better and faster compared to the existing 4G and 4.5G network. 5G networks have very low latencies, which is a latency of 1 millisecond compared to the 4G networks, which have a latency of 50 milliseconds. Based on these stats, 5G is said to have 50 times lower latency compared to 4G. 5G networks also have 1,000 times bandwidth per unit area, making it more significant compared to the existing generation network. Comparing 4G LTE with 5G, 5G enables up to 100 times the number of devices that can be connected within an area, which is significantly more efficient compared to the 4G LTE. 5G network is said to be almost entirely available at any given time with the availability rate of 99.999% as well as having 100% full coverage. Now we will talk about the architecture of 5G. The 5G architecture consists of all radio access networks, also known as RANs, aggregators, IP networks, nanocores, and etc. The 5G protocol stack consists of open wireless architecture, lower and upper network layer, open transport protocol, and the application layer. Figure 1 depicts 5G network architecture. As shown, 5G network uses flat IP concept so that different RANs can use the same single nanocore for communication. 5G uses millimeter waves that occupy the frequency spectrum between 30 GHz to 300 GHz. This differs from the current frequency spectrum that uses frequencies between 3 kHz and 6 GHz. This is because the current frequency spectrum used for mobile devices are starting to get crowded as carriers can only squeeze so much bits of data on the same amount of radio frequency. By increasing the range of frequency spectrum, it increases the amount of bandwidth for data transmission. However, a limiting factor of millimeter waves is that it cannot travel well through buildings and obstacles and can be absorbent towards rains and plants. Next, 5G will be implemented and spread throughout the city using smart cells. Smart cells are towers or stations that is used to increase the overall coverage of 5G networks that leads to increasing its availability at all times. 5G will be using an infrastructure known as Massive MIMO, which stands for Massive Input, Massive Output. Massive MIMO are stations that have large number of service antennas, up to hundreds or thousands. Its main functionality is to transmit a high volume of signals in a smaller region of space, thus resulting in better improvement of connectivity. 5G uses a technique called beamforming. It is simply a process that allows you to focus your signal directivity. By implementing such a technique, higher signal strength can be achieved. 5G is said to be a full duplex connection rather than the existing generation networks, which are half duplex, making it accustomed towards better connectivity. With all these improvements towards a better network generation, you may be wondering what can this really be used for? Well, 5G provides a perfect application for smart cities. So, what is a smart city? A smart city is defined as a metropolitan area that gathers information through different types of electronic data collection sensors to manage a city effectively and efficiently. It's believed that smart cities can help to increase and improve the daily lifestyle of citizens by using these collected data to monitor and manage the city. A smart city represents a technologically advanced city that is clean, friendly, and a city that is tightly packed with the network connections that offer many benefits such as a better transportation system. The current 4G network is insufficient for a fully integrated smart city, as it cannot provide the same speed, bandwidth, and low latencies as a 5G network. The capabilities of 5G are expected to drastically increase the speed of connectivity, seamlessly connecting things in the sensor layer and the application layer, while incredible amounts of data will be collected and managed in the platform layer. The network layer and the platform layer are more behind the scenes, but are perhaps even more important, as this unseen layer controls everything. The network layer refers to the internet, the power grid that is connecting all of these devices. The platform layer is the management of this network layer and refers to the information processing, coordination, management, storage, security, and control. All of these things come to work to make citizens' life more connected, more convenient, safer, and much more secure. It is definitely a bright future ahead. So now we will talk about the applications of 5G in smart cities. There are a lot of applications of 5G in smart cities. However, in this video presentation, we will be only covering a few of the examples. To implement a smart city, it would require that the autonomous vehicles, smart city energy grids, transportation networks, and water systems to be all controlled in the cloud. Such futures, however, won't come into reality unless the path to the cloud is low latency, ultra-fast, and secure. This is where 5G comes into hand. As previously mentioned, it is 10 or to 100 times faster than 4G LTE, which is already considered to be very fast. This super speed is required as when dealing with such safety concerning applications, such as in a self-driving car. If a car was to take a half-second delay in making the turn, it could lead to a dent in your car or even serious accidents. While we're on the topic of self-driving cars, Tesla, a company which develops self-driving cars, has been rising in the popularity lately. And with the help of 5G networks, we can fully implement driverless cars as it provides very low latency and delay. Furthermore, the self-driving cars and other connected cars can share information with each other. So if an accident occurs, the car closest to the accident can wirelessly send information back to all the cars behind it on the highway. Therefore, these cars can take another route and it would reduce traffic congestion. Furthermore, the sensors in the smart car will be able to take more accurate measurements about the weather conditions in different geographic locations. And that data can then be sent over the 5G network back to the cloud, so that the self-driving car can calculate a better route to take and make adjustments to your journey. We can think of this concept as something familiar to the popular app Waze. Talking about Waze, we might not need it anymore if we implement 5G. Cars can talk to traffic lights or other vehicles, and they will send the traffic intensity information to the cloud, and the cloud will send it to other drivers and notify them of other routes to take based on the traffic intensity. Furthermore, this will also allow for the traffic lights to control traffic congestion based on the number of cars. Therefore, we will no longer have to wait for a red light in the middle of the night at an empty junction. This does not only apply to cars. By implementing a 5G network, it will virtually allow vehicles to talk to each other. This is especially useful in public transportation such as buses. We can easily implement smart 5G bus stops as shown in the picture. The smart bus stop should have sensors or a button that indicates there is a person or people waiting at the bus stop. If there is no one currently waiting at the bus stop, the bus driver can skip this bus stop and go to the next one instead of having to waste time. It also allows for bus operators to send out additional buses if there is a congestion due to accidents or traffic jams. We all know that parking can sometimes be a nightmare. To ease the parking struggle, the city could have installed smart parking technology that allows drivers to check a mobile app, website, or even call the hotline for real-time availability and cost of parking spaces. To detect whether spaces are occupied or open, wireless sensors on more than 5,000 parking spaces should be implemented on each of them. And to allow for all of these wireless sensors to run smoothly without errors, this is where 5G comes into play. The current waste collection system is very inefficient. If you walk around the city, don't you see some garbage waste containers which are piled up and overflowing? Whereas some other garbage bins are empty. By integrating a smart waste collection system with the aid of 5G, it can very much improve the efficiency of the waste collection system. As smart bins can indicate the level of waste it currently contains, Garbage trucks won't need to travel to areas with where the bins are empty, and more frequent visits can be made for the bins which are flooded. The smart bins will be used as these bins contain sensors that allow it to detect the weight of waste and will automatically compact these waste, allowing it to hold up to 8 times the waste of a normal garbage bin. These bins can also provide other services for a smart city. For instance, act as a Wi-Fi hotspot. Now you might be thinking that a waste collection system doesn't require low latency or 5G, as if there is a short delay, what is the worst thing that could happen? We're not dealing with self-driving cars. Well, 5G is useful here not because of the low latency, but mainly because of the high bandwidth and coverage that it provides. Think of all the garbage bins in your city and having them connected wirelessly throughout the cloud. It would definitely require a lot of bandwidth. Furthermore, these smart bins are not just normal bins. They will contain mobile hotspots, CCTV cameras, and other sensors that are required in building a smart city. So to try and wrap things up, what is 5G? Basically, you can try to think of 5G as the next generation of wireless connection, where you can download a very high definition film, possibly under a second. But how does this help with smart city? Well, without the low latency, ultra fast and secure connection, a smart city wouldn't be a smart city, and 5G fits all the criteria in it. Although it costs a lot to develop a 5G network in a smart city, think of 5G as an investment. It can actually help save money in the long run and also make the city a better place. Therefore, it is in fact very cost efficient in the long run. For example, the city can manage traffic using variable toll pricing to combat congestion and speed traffic flow. Do you want to drive into a busy city at rush hour? The camera will take a picture of your car plate and will automatically charge you at the toll. For the result of this system, traffic flow across the city will be very much improved. So that leaves us with the question, is 5G actually worth being implemented to a smart city? Well, if you ask me, I would say yes.